A housing contractor has subdivided a farm into 100 building lots. She has designed two types of homes for these lots, colonial and ranch style. A colonial requires 30,000 of capital and produces a profit of 40,000 when sold. A ranch style house requires 40,000 of capital and provides 8,000 profit. If the contractor has $3.6 million of capital on hand, how many houses of each type should she build to maximize her profit? All right, so I need to find, first of all, my variables, define them. So X is going to be the number of colonial houses, and Y is going to be the number of ranch style houses. So if I take the number of colonial and I add it to the number of ranch, there are 100 lots, which means that this can be no bigger, so this needs to be less than or equal to 100. The next idea is how much money we're going to make. So we're going to make how much it takes, not make. It takes 30,000 to build the colonial and 40,000 to build for every ranch style house to build. And this needs to be no bigger than $3.6 million. Because I can't spend any more than that much money. Now, the money that I make is going to be 80,000 for ranch and 8,000 for ranch and 4,000 for the colonial. So that is going to be 4,000 X plus 8,000 Y, and this is going to be my profit. This right here is what I'm trying to maximize. So now I have my system of equation. Now there's a little bit more to this. You have the X needs to be bigger than or equal to 0, and Y needs to be bigger than or equal to 0. Mainly because I don't want to build negative houses. That doesn't make sense. So we got to put that into it. And then with that information, we have our system of equations. Now, if I divide 30,000, 40,000, and 3.6 million, and I divide it by 10,000 each, I end up getting, now bear with me, 3x plus 4y, and that needs to be less than or equal to 360. So, now, if I solve for all of these, I end up getting, and I'm going to have my new system down here that's solved for. We have y is less than or equal to negative x plus 100. And then we have y equals negative, once I solve it, negative 3/4 x plus 90. Yep. And then x is greater than or equal to 0, and y is greater than or equal to 0. Now, let's graph these. And if I make each one of these tick marks 100 each, you'll end up getting 100, which goes up to 10. And then it's down 1 over 1, down 1 over 1, down 1 over 1. So it's going to go down to here. And this is going to be a solid line. And then I have my blue line, which is going to be 90, which is going to be right here. And then it's going to go down 3 and over 4. Down 3 over 4. Down 3 over 4. So that's going to look like this. And then I have the purple, which is going to be this line right here and this line right here. It's going to be greater, so that's going to go this way. This is going to go this way. The red is going to go this way, and the blue is going to go this way. So my answer actually ends up being this bounded area right here. Now, as we know, the maximum profit is going to happen at the corner points. So we have this point right here, 0, 0. We have this point right here, which looks like it's going to be 10, so it's going to be 100, 0. We have this point up here, which is going to be 0, 90. And then we have this point right here, which is actually going to be 40, 60. Mainly because it's going to be 4 over, which is going to be by 10, so 40, and then 6 up, which is 60. So 40, 60. Now what I'm going to do is I need to maximize this profit, and the only time the maximization is going to happen, which is the cool part about linear programming, is it's only going to happen on the corners of your shaded area. So I plug in this, 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 and this into this equation. Whatever's biggest is going to be where I'm going to make my most profit. So I'm going to start off doing this point right here. So if I plug a 0 into here and a 0 into here, you end up getting 0 plus 0 is going to be my profit. So here my profit is going to be 0, which makes sense because if I don't do anything, I'm not going to make any money. And then I plug 100, 0 into here, so it's going to be 4,000 multiplied by 100 plus 8,000 multiplied by 0, so that gives you 4,000 and then 2 more zeros, so 400,000 plus 0 is going to be my P. So my profit here is going to be 400,000. And then I'm going to plug this point into there. So I have 0 times 4,000 plus 8,000 times 90. So that's going to be 0 plus 8,000 times 90, which is going to be 72. One more 0. So that's going to be 720,000. So P here is going to be 720,000. And then I have my last one, which is going to be this point right here. So I'm going to plug 40 in here and then 60 into here, which ends up giving me 40 times 4,000 is going to be 16. It's 160,000 plus 8,000 times 60, which is going to be 48, 480,000. And then I add those together, that's going to give me P equaling, let's see, 0, 0, 0, 0. 8 plus 6 is going to be 14. Carry the 1, 5, 6, so 640,000. So out of this profit, and this profit, this one is going to be the biggest. So I'm going to make my most money if I build 0 colonial houses and 90 ranch houses. Now this is interesting mainly because I'm going to have 90 ranch houses and 0 colonial, which means I'm going to have 90 houses. But I had 100 lots to begin with, which means there are 10 lots that are not being used. So will any of the lots be vacant? Well, yes, 10 of those lots will be vacant. So there is my answer.